Alright, as we look at today's Do Now, it looks at scale factors, which we've talked about before, but today we see this one talks about scale factor in terms of percentage, which looks very familiar to something that we've already seen before. So we can see that this is talking about a percent of the real size, and so we can see that we can apply our Q is equal to percent times whole, just as we did with anything else. So we have 25% of 0.25% of the whole, and it tells us the real size. And in fact, when we talk about scale factors, we're always going to see that the whole is going to be the original. And this is going to seem very familiar to us just because anytime we've seen these percentage problems, we always talked about the whole being the original. The real basketball is the original. So we're going to plug that in for 10, and that's going to give us that our Q, or in this particular case, the size of our scale drawing is 2.5 inches. Going back to what we talked about in Unit 1, this is the same problem. We talked about percent or fraction of whole meant 1/4 of 10. So it's the same idea, except for in this particular case we have it written as a fraction. 10 over 4 is equal to, 10 over 4. And that also gives me 2.5. And that's how we learned about it before. But we can easily see that in these two problems, if we link the ideas together, this 1/4 is the same thing as this 0.25, or that 25%. So it's the same concept that we've learned before. Now we just have a different concept of way to putting into it based on percentages. So let's flip on over and look at our aim for today. Alright, today's aim, Kipsters will be able to use Q is equal to percent times whole to solve scale problems. Alright, so when we look at these particular drawings over here on the right, it looks kind of like they've created a snowman here, and we can see here that the original is here in the middle. So this first question is asking us to compare the lengths of figure A, so this one's figure A, to the original octagon in the middle. So if we're going from the original to figure A, and we're making this scale drawing, we often would call this a reduction. And this comes from the root word of reduce, which we know means to get smaller. So why would we call this a reduction? Well, to reduce means something to make something smaller. So in this particular case, it's a reduction because the figure is made smaller. When we look at the other direction, when we're going from the original to figure B, which we can see is larger, we call this an enlargement. And we can see that word large in there as part of our root word, and enlarge means to make larger. Explain why this is called enlargement. Well, it's because the figure is made larger. So if we use those root words, we can see that these two definitions seem to make plenty of sense. Alright, so the scale factor is the quotient of any length in scale to its corresponding length in the actual drawing. So what does that mean? Well, we recall from Module 1 that the scale factor between the original and figure A and figure B. So the quotient And basically, this is a ratio of corresponding to actual. So as we look at this example, and we look at the scale of the height of this, we would see these are corresponding sides, the vertical corresponding sides. Our scale is 2 to 4. Again, this is the scaled to the actual, which is equal to 1/2. So that's just one example. And so let's go ahead and look down here at the bottom. Now, we're going to use the diagram above to create a chart to determine the horizontal and vertical scales. And we're going to write it as a percent and then a concluding statement to think about reduction and enlargement. So when we look at this particular case, we can have horizontal and vertical scales that are different. A lot of times we'll see this in different scenarios where perhaps we're trying to fit something on a particular page and we want to do that. Most times when we scale things, we do scale the vertical and the horizontal similarly. That doesn't seem to stretch or skew, so things still look in proportion. In this particular problem, it looks like most things are still in proportion, and so therefore I would assume that the scales of vertical and horizontal are the same. But let's test that out. So we've already done the vertical for figure A to the original. 2 to 4, which reduces to 1/2. And to change that to a percent, we get 0.5 or 50%. So for the horizontal, again, we're going from the scaled to the original, 1.5 to 3. This is 1.5 to 3. And if I do that division, I'm going to get 0.5, or once again, 50%. So we can see that we've scaled this one the same way. Now we look at our percentages here, 50% and 50%, which means it's 50% of the original. And write this as a concluding statement. The figure has been reduced so figure A is 50% of original. Now, in the second one, again, remember it always goes from the scale to the original. So in looking at this one, as we start to write this one, we have 6 to 4. So the original is 4. So the scale drawing is 6 to 4. So as we write that down, for our vertical, 6 to 4, that simplifies to 3 to 2, which is 1.5, or if we change that to a percent, 150%. What we can see here is that the percentage is larger than 100%, which makes sense to us because if we have something that is greater than 100%, it's the original size plus some more. As we look at the horizontal, we're going from our scaled is 4.5 to the original 3. So 4.5 to 3. Again, if we do that division, we once again get 1.5. So we get 150%. So in this particular case, we see that it's an enlargement. The figure is enlarged to be 150% of the original. And once again, we can link that to the idea that we see these are greater than 100%. Alright, so as we look at the work here, we're going to create a snowman on the accompanying grid, and we're going to be using the octagon below, very similar to this one over here. We're going to be using scales to kind of create the head of the snowman and the bottom of the snowman. So in order to do that, the first thing we're asked to do is we want to label the width, neck, and height of the figure above. So I'm looking for us to match a length for this, a length for it to go all the way across the far end, and to measure the height as well. So we can see that this is a little bit stretched in terms of what our view looks like, but if we do so, we should be able to count that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our original here is 12. Coming across, we can count out that this is 20, and that our original height is also 12. So we can see that this isn't quite drawn with perfect squares, and that's why we get this shape that looks like it's a little bit skewed. We see the horizontal 12 and the height 12 as well. Alright, to create the head of the snowman, we make a scale drawing of the middle of the snowman with a scale factor of 75%. So calculate the new length for the snowman's width, neck, and height. And then we're asked, is the head a reduction or an enlargement? We should be able to immediately answer that question by looking at the percentage. If something is 75% of its original, is that going to mean it's a reduction or an enlargement? So consider that for yourself first. Turn and tell your teammate whether you believe it's a reduction or enlargement. At this point, you and your teammate should have identified that if something is 75% of the original, it's going to be smaller. It's some fraction of the original, and so this should be a reduction. Alright, so looking at this, we're going to use Q is equal to percent times whole. Our whole is always our original, and so what we'll do here is we'll go ahead and do a calculation for the width, the neck, and the height. So our scale drawing, we'll put in for Q, we'll just call that S, is equal to, actually we'll just go ahead and use the variables that I used off to the side, W, N, and H. Those are going to be our new scaled for the width, the neck, and the height. Our percentage in all these cases is 75%, and so that's going to be 0.75 times our whole. And our whole for our original, for the width, so the whole entire width we said was 20. And our neck we said was 12. And our height we said was 12. So go ahead and calculate really quickly what the width, neck, and height would be based on your equation. Alright, so as we look at this, we do this multiplication, we should get 16. This one we should get 9, and we should get 9. So what we see here is that, again, this is a reduction, 16, 9, and 9. So go ahead and draw a snowman head on top here that is 9 units wide, or sorry, 16 units wide in total. It's 9 units at the neck and 9 units high. So go ahead and draw it, and then come back and just double check at the video to make sure that yours looks the same. If you need a little help getting this drawing done, my suggestion is to go ahead and identify the center line of your snowman. So this is kind of like my center line of my snowman. And I'm just going to draw that in to kind of help guide me in drawing the snowman. I started by measuring the height here, so it's going to go all the way up to this height line, so that's 9. And then if I have this equally, and it says my neck is going to be 9, that means at my neck this needs to be 4.5 on each side. So that's a little bit more than 4. So I have 1 point down here, 1 point down here at 4.5, 1 point up here at 4.5, and another point up here at 4.5. And so this would be the top of the head and the bottom of the neck. And the width is supposed to be 16, which means out at this, it's supposed to be a total of 8. On each side, so 2, 3, 4, 5, 6, 7. So I'm going to count this out. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to connect and connect. And 1, 2, 3, 4, 5, 6, 7, 8. Now connect and connect. Alright. Alright, so we've done the head. Now we want to create the bottom of the snowman. We're told the scale for the middle of the snowman is going to be a scale factor of 125%. So thinking about that percent, go ahead and turn and talk with your partner. Is this going to be a reduction or an enlargement? And then tell your teammate why you believe it's going to be a reduction or an enlargement. You and your partner should have identified here that this is going to be an enlargement. The reason is that it's 125%, which means it's 100% of the original plus some more. So when we use our equation, Q is equal to percent times whole for our width, neck, and height. This is going to be 1.25. Again, that's 125%. Decimal 2 times is 1.25 times the originals is 20. 1.25 times 12 and 1.25 times 12. Go ahead and do those calculations on your own. We should get for this one that this is going to be 25. For this one, we're going to get 15. And for this one, we will get 15. And actually, I'm noticing a calculation error myself. Coming back up to this one was miscalculated. This one actually should be 15. So as I go up to my snowman drawing, I guess I'm going to have to bring these in just a little bit. 7.5 on each side, and 7.5 on each side. Alright, so coming down here, we want to go ahead and draw this. So again, I'm going to do this the same way that I did before. I'm going to start with my height. I see that my height is now supposed to be 15, so I'll come down my center line and count that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I'll go ahead and draw my my neck changes from to 15. So that means 7.5 on each side. So 1, 2, 3, 4, 5, 6, 7.5. And same thing on the other side. 7.5. And the same thing on the bottom, so coming down here, 7.5, 7.5. And looking at our width is now supposed to be 25. So that's going to be 12.5 on each side of my center line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5. And we can just connect it out. 12.5 on the other side. 1, 2, 3. I'm just going to bring it out down here. And we've got our full snowman drawing. So as we flip over here, we have this one key question that kind of thinks about what is the significance of the scale factors as it relates to 100%. So in other words, I'm asking you to consider what happens when each scale factor is applied. So something that is greater than 100% and something that is less than 100%. What happens when your scale factor is greater than 100%? Well, we should recognize that this means that it is an enlargement. And when something is less than 100%, then it is a reduction. As we look at the problem below, it says sometimes it's helpful to make a scale drawing where the horizontal and vertical scales are different, such as when creating a diagram in the field of engineering. Having a different scale factors may distort the drawing, and next to the drawing below is a scale drawing that has a horizontal factor of 50% and a vertical scale factor of 25%. And it's given in 2 steps here. Explain how each drawing is created. So we move from our first drawing to our second drawing, and it explains to us that it's only given a horizontal scale factor of 50%. So we can see that horizontally it is squeezed together, and the next one we're told has the scale factor of 50% but also has the vertical scale factor, and so we can see that it is also squeezed vertically as well. But we can see that it doesn't look like it's quite in proportion to the way it used to be. So it used to look like this was 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8. So it looks like this used to be a square, but now on the bottom we see that it is a rectangle. So we can see that that scale drawing is distorted by the fact that it has a vertical and a horizontal difference in its scaling. So when we look at the horizontal and vertical scale, we have to look at each distance in terms of which way it is actually scaled. So there are 3 major measurements here. One is the width of house. And so when we look at the width of the house, it is currently 8, so the scale would be Q is equal to % of whole. And again, always the original is our whole, so the width is originally 8. And this is going to follow our horizontal scale factor, which is 50% or 0.5. So the width of the house we see changes to 4. As we see down in the drawing, this is correctly done. So looking at the height of the house, and we're just going to talk about the height of the base of the house. It has a different scale factor. So when I plug in my percentage here, it's going to be different. What am I plugging in for the percentage in this particular problem? Well, the vertical scale factor, which this is measuring up and down, is 0.25 times the original, which gives us 2. And the final measurement we can talk about is the height of the roof. We have to ask ourselves, is that a vertical or horizontal? And that is a vertical measurement, so it's going to follow the vertical scale factor percentage. And so in this particular case, it's going to be 0.25 times the original, which was 4, which we can see on the drawing is a height of 1. All right, so go ahead and use the space below, looking at this next problem, to draw a scale drawing of the arrow. I'll give you a couple of hints here. There are really four major measurements that you need to worry about. The first major measurement would be the width from the end of the arrow to where kind of the rectangle begins. One measurement is kind of the height of this part. The next measurement would be the height of the arrow, and then the next measurement would be kind of from here to here. So breaking this down into four different measurements, we're going to use a scale factor of 150%. So for me, again, I'm looking at this as a rectangle length and height, or base and height. So I might call them the length of the rectangle's base and the length of the rectangle's height. And then I think about just the arrow part. I might think about the length of the arrow and the length of the arrow's height. These are the four measurements that I need to enlarge using Q is equal to percent times whole. Go ahead and do that on your own. So calculate it and then draw. So going through your calculations first, Q is equal to percent times whole for all of them. Q is equal to percent times whole. We have here that this is going to be 1.5 or 150% times the whole. So notice we have a scale factor of 150%, so we assume that's true for vertical and horizontal. 1.5 times the original is 12 is going to give us 18. So the length of the rectangle should be 18. So I'm just going to start with a space here. And I'm going to count out to 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's going to give me 16 is my length there. And Q is equal to percent times whole for its height. Well, its height is currently 2. So it's going to be 1.5 of 2, which gives me 3. So my height is going to be 3. I draw that on here for my rectangle. And I can finish drawing out my rectangle. So this is going to be my rectangular portion. And now I need the height of the arrow portion. I'm going to deal with that first. So Q is equal to percent times whole. And it's originally 4 units, which means my final is going to be 6 units. So this is 3. That means I need 1.5 units on either side. So I'm going to stop it here, and 1.5 units on the other side. Stop it there. And now I need to know where to connect it. So I need to know the length of this, and originally our length is 4. Q is equal to percent times whole. And we've actually already done this calculation. That's 1.5 times 4, which is 6. So my center line here, 1, 2, 3, 4, 5, 6. And we're able to draw our scale drawing. And so this is our arrow. You're going to do the same thing over here. In this one, we're looking at this. For our scale drawing, we're using the vertical and horizontal scale factors. So there are different scale factors for our horizontal and our vertical. There are really only two measurements in this particular one. We have our horizontal measurement and our vertical measurement. So that's going to make the calculations a little bit easier. Go ahead and do this one on your own, and then we will move forward. Make sure you've already done your calculations first before you do your drawing. A couple quick hints on the calculations over here. This one is pretty self-explanatory for the vertical. 25% of 4 is 1. And for this one, I moved my decimal and it's 1.83 repeating. So what I do when I put this in my calculator is I just put as many 3's in there as possible, and I know that it's eventually going to round up, and so that I get, in this particular case, my calculator tells me 10.999999998. I know that because I just approximated that, that would actually round up to 11. So when I come over here and do my drawing, pretty easy drawing, a height of 1. And then on either side I need 5.5, so 5.5 and 5.5. And so this is a really skinny and kind of difficult to draw. Probably need a ruler for that one. Alright, Chris is building a rectangular pen for his dog. The dimensions are 12 by 5. He's building a second pen that's going to be 60% the length and 125% of the width. Write an equation to determine the length and the width. So we're just going to have you write the equations for the length and the width, and then you'll be good to go. So go ahead and do that really quickly using your Q is equal to percent times whole. And just because I think this is a little bit confusing, let's go ahead and call this the length, and let's call this the width. Alright, so hopefully that will help you sort that out. In my calculations, I'm going to use my width. I'm going to label that as WI, width of my scale drawing. Alright, so my two equations, my width has a scale of 125%, or 1.25 times 5, and my length is a 0.6 times 12. Alright, so go ahead and move on to your alone time.